So you can check through those real quick. Yes, well, I take attendance. Maybe. Maybe. You have half a bag of Doritos?
I was talking to Emma, but if you want that, you can also have some.
On the other side of this. Gosh, Brody. Brody. All right, let's see who we've got in here. Brody, Claudia, Nora, Noah, Lena, Leo, Jonah, Chris, Emma, Gavin. Gavin, are you home?
Yeah, I'm here.
All right. They want to know why you're at home.
I got my second COVID shot and then I didn't feel good.
You didn't feel good.
No.
I went on a 5-mile hike the day I got mine, and then went camping the whole rest of the week, man.
Then you have an impressive immune system.
Hey, thank you. Gabe. Gabe is out there. What? Forward favored means the forward reaction is faster than the reverse. That is true. Oh, I'm sorry, wait. Forward favor means the forward reaction is going faster than the reverse. Why do I have false there? There we go. Make sure you correct your picture, Emma. Ah. That's a true. Boom, 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 boom. That's what happens when I get working too fast. Let's see, make sure. Nick, I saw you're for AP next year. Good. Looking forward to it. Actually, I saw you're on AP next year, or Emma's on AP next year. Claudia's doing AP Psych next year. Is John not here today? John Saunders?
Wait, did you
John?
did you have to do intro cycle?
I don't see him. All right.
What's the one?
All right, the other side of this. Today we will be using one of these calculators. So if you have one of these and you don't have it prepared, go ahead and grab it. Is the one on your desk? Did you-
Wait, can you show that again? I don't know how to use that. I only use the one on-
Oh, this one, yeah.
Oh, it's just a graphic one.
Yeah. Everybody need one for here. Everybody has one of these.
I don't
You do,
I don't know.
but you're gonna have to do that. Otherwise, you have to do this quadratic equation. Quadratic equation.
Yeah, it's so.
We'll have you sing it after. All right, so there we go.
Wait, Mr. Jackson,
Yes.
could you go over number 11?
Number 11 here.
Yeah.
Yep. So we said that if you you don't worry about solids usually, right?
Yeah.
If I remove all of it though, every bit of the solid, at least a small amount will have to form.
Okay. And then, okay, that makes sense. And then number 16, why is there no like change?
Because the number of moles of gas on both sides are equal.
Oh, I didn't realize, I forgot I had to. Yeah. Okay. Thank you.
Yep. This is canvas. This is the recording. This is the recording. The recording will be on there. I might be able to print them out or put a scan them in. All right then. Are we good? 17. Add a small amount of neon gas. So since it's the same on both sides, that's not going to affect anything. In reality, yeah. Here, even adding a small amount of helium gas is going to do nothing because it's going to affect the concentration of both of them the same.
Is it because helium is not like part of the reaction? Is that why?
Yeah, it is. So it's basically affecting it. Like it's just like increasing, changing, it doesn't change anything. The ratio is still going to be the same. No, because if we add more oxygen, oxygen is a product. So it's going to make more reactant, right? I don't know what you're asking because you're just using words like that's the same thing for that one. So I need to be more specific. So we'll move on. Add more what? Neon. So where is neon? This is nitrogen. Yep. And then yesterday you were to do the whatchamacallit? You were to do these guys. I'll let you take a look at those. I'm gonna go grab a drink real quick.
Oh, yeah, Monday.
What? Sure. That's the Monday, that's the idea. Questions on any of these? Yes, is it number 9?
Yes, it is.
Number 9, the fact that we don't have any SO3 at all means that we have to form some. Just like here, we don't have any products, so we have to form some products to get to reactants. Here, we have to form
So-
some reactants.
So do we just express Q as 0 in number 9, even though it's like 1 over 0?
That's what it comes out to be, right?
You do like 1 times 1 over 0.
Is
So
it
like,
undefined?
yeah.
Yeah, there you go. Boom. How's that? Good. Yes. Take a look here. I'm going to introduce the ICE method or RICE method. You call it ICE or RICE, Akshay?
Me?
Yeah.
Ice.
Make sure you're not sticking your hands in there. You're pouring them out, right?
I'm fine, that's fine.
Good, good.
That's what I- I know we have to. Ready to take it.
You even like those things? They're terrible.
What do you mean?
Yeah, that's why I gave them to you.
What's the candy?
Owen hasn't had them. Like, I like these things. Like,
Oh, those are awesome.
these like are actually really sour.
Sour candy is the best.
Those like, I don't like jelly beans though.
I like them. What do you think?
What? Yeah. So let's take a look at those. How about we take a look at this one right here? So copper sulfide. Up here, all you did was make the K expression, right? K sub EQ. Actually, this is a specific K, solubility product constant. And we know all of this is going over 1 because this is solid. Basically, we have a beaker and there's solid in there and some of it's dissolving. Some of it's being pulled apart by the water molecules. So then we have Cu plus concentration squared, and S2 negative concentration to the first. We all agree on that? So then we're going to do what's called the Rice table, which stands for reaction, initial, change, equilibrium. We don't care about this thing at all because as long as there's some solid, it's going to be there. It's one, right? Doesn't really have a concentration. It's just one. This, at the start, we have initially nothing. So we are going to lose a certain amount of that. We're going to lose 1x of it. For every 1x of it based off the balanced equation, we will get 2x of copper, and we will get 1x of sulfide. With me here? No?
Wait, can we just keep it sealed? Is there like a ceiling button?
Yeah, that's what it is. A 1 to 2 to 1. So then at equilibrium, we should have 0 plus 2x, which is equal to 2x, and 0 plus 1x, which is equal to x. At equilibrium is when we are at the KSP, right? So those are the concentrations at the KSP. So KSP is 1.6 times 10 to the negative 48 equals 2x squared times x, which equals 4x cubed. Is that right? So 4x cubed, we're going to take 1.6. 1.6 times 10 to the negative 48 divided by 4. And then cube root that. How do you do cube root? To the 0.33? So you get 1.06 times 10 to the negative 16th, is that right? Oh, it did, well, that if you took it to the 1/3. 1.6 times 10 to the negative 48 divided by 4. What do we have to do? We have to hit, like, is there a math or something? There we go. Answer. Taking the cube root of this. There we go. 7.36. 7.37 or 7.4 times 10 to the negative 17. That is the molar solubility. Number 10. Explain it more. No, and that's what we're going over today. Number 10. For these, the initial will be 0 because we're dissolving this, right? So we don't care there. 0, 0. Because we're taking this and we're putting it in here. Plus x plus 3x. Because initially we took this solid and we dumped it into water. What happens whenever things that are soluble are dumped into water? They start to dissolve. What's the question?
Oh, nothing.
Oh, you just answered it. So there's that, right? And we know that case of SP equals Fe3 plus OH minus cubed. So these then are the concentrations X and 3X at equilibrium. So we're going to pump those into there. So we get 1.1 times 10 to the negative 36 equals X times 3X cubed, which is
It's like 27x to the 4.
27x to the 4th. So we are going to take 1.1 times 10 to the negative 36 divided by 27. And then what? Is there a math for this one? Oh no. 4? And then answer. Oh no. I'm not very good at these. Right? 4. And then answer. Boom. 4.5 times 10 to the negative 10. Two significant digits. Yeah. No. If we oh, how should we say this? This is the concentration of this dissolve. But if we wanted to find the how many hydroxide ions were in there, we would then multiply that by 3. Right? Does that make sense? They call it the molar solubility. So that's how many moles per liter at a particular temperature iron 3 hydroxide would dissolve.
Could I see 11 and 12?
Yep.
Also, Mr. Jackson, you wrote 10 to the negative second, but it's 10 to the negative 10.
I wrote 10 to the negative second.
Yeah.
Thank you. It should say 10 to the negative 10. There we go. 4.5 times 10 to the negative 10. Do you want to see 11?
I just want to see the answer. I didn't get to have a chance to.
There we go. 6.9 times 10 to the negative 5th.
Yep. Okay. Thank you.
And there is 12 and 13. And there is 14. What?
So I don't think it makes sense.
Yeah, if you can mathematically do these, that's okay, but the next thing you'll have to do the right thing. You'll just have to get used to it.
So I just feel like, it's like,
Yeah, like I showed the video. I just made the equation, right?
yeah.
Yep.
and then put the,
Yep.
put to the power of the-
These are easy because there's one on the we don't have to worry about the reactants, but they get harder. And that's why I wanted to kind of introduce the right thing in an easy circumstance. All right, let's make it hard. So we'll start off pretty easy. So it says when 4 moles of PCl5 is heated in 1 liter flask, an equilibrium is established in which 0.25 moles of Cl2 is present. What are the equilibrium concentrations of these two things? So they say that we are going to put 0.4 moles per liter. So the concentration of this is 0.4. And we don't have anything else. So those are zeros. What is the change? Well, reactants are going to have to make these products, right? So we're going to lose 1 reactant mole, and we're going to gain X product mole. So here at equilibrium, this will be 0.40 minus X. Here, this will be X. And they actually tell us that at equilibrium, we have 0.25 moles per liter. So that means that X must equal what? It says at equilibrium, as equilibrium is established, 0.25 moles of Cl2 is present. So that means X must equal what?
2.5.
P5, right? If this is 0 plus X, and that equals 0.25, then X must be 0.25. So this is what are the equilibrium concentrations of PCl5 and PCl3? Well, we take 0.4 minus 0.25.
0.15.
And here we have 0.25. And here we have 0.25. Could we find K for this?
Yep.
Yeah. 0.25 squared divided by 0.15.
The answer is 0.416667.
Well, there we go. Easy enough. Point 0.4 minus X. And X is 0.25. Because it said that at equilibrium, the concentration of Cl2 was 0.25 moles per liter. Oh, there's only one X. Because we lost X amount of this, and we gained X amount of these two things. All of the X's. So, if we take a look here, this time it's 4 moles put into 5 liters. 4 divided by 5.
It's 0.8.
0.800 concentration starting out of HI. Once equilibrium is reached, there are 0.442 moles of I2 present. So at equilibrium, we get 0.442 divided by 5.
It's 0.0884.
There's our molar concentration of I2 at equilibrium. How much I do we have at the start? How much iodine do we have starting with? 0.
Zero.
So those are zeros. Now what's going to happen is we're going to use up reactant to make product, but every 2x makes 1x. These are concentrations. Remember, the case of EQ that deals with concentrations, right? So what does this mean? This is 0.800 minus 2x. This is x. What is x equal to? 0.0084. It's the moles per liter of iodine. It says once equilibrium is reached, that's how much iodine is there. The E for what? This? Because it's 0.800 minus 2x. Yep. This is the initial, this is the change, and then this is at equilibrium. 2 times 0.0884.
The answer is 0.176.
0.8 minus 0.1768.
That would be 0.6232.
So there are all of our concentrations at equilibrium. So if we want to find K, .0884 squared divided by 0.623 squared.
The answer is 0.0201.
I think, did I say 623 or 632? I'm talking to you.
It's 0.623.
It is? Okay. 0.623. Point 623. All right, let's try it again. 0.0884 squared divided by 0.623 squared.
The answer is 0.02019.
Boom, there we go. So there is the cake. Shall we try another? Yes, Owen. Okay, you guys aren't getting this. These are concentrations, right? So how do we find the concentration? What do we have to take? Moles divided by liters, right? So of iodine, how many moles are present and how many liters is the container? Yep, moles per liter, moles per liter. That's how do you think I got the 0.8, right? 4 divided by 5. Yep, moles per liter. Brody. Bring it up here. Let's take a look at your calculator. I didn't find it notation.
It scrolled a little bit. I didn't like redoing.
0.0844 square. Why did you put 0.0071 square? It's 0.623. Boom.
And I didn't put that font.
What's that?
I think I put the. I did the.
Oh, maybe the watch can't do it. Let's try it. 0.0884 square divided by 0.623 square. Yeah, calculator can do that. That's fine. Yes. Okay. All right. So if we take a look, here's our reaction, right? So we have 0.298 moles of PCl3 to start with. That's for how many liters? 1. So what's 0.298 divided by 1? So that's the molarity for the PCl3 at the beginning. We have 8.70 times 10 to the negative 3 moles of PCl5 per liter. So that is the molarity of the PCl5. How much Cl2 do we have at the beginning? No. 0. It's not until equilibrium is established that we have 2.00 times 10 to the negative third. So every one of these, how do I know I'm going forward? Because I don't have any Cl2 to start with, so it has to make Cl2, right? Gains one of these, gains one of these. So X here is 2.00 times 10 to the negative third. So I have 0.298. 0.298 plus 2 times 10 to the negative third gives me 0.3. No, I added this X to get this. This is X. So then we'll take 8.7 times 10 to the negative 3 and do what? We will subtract. Yeah, this isn't easy, right? There's a lot going on. 2 times 10 to the negative third. So we get 6.7 times 10 to the negative third. Now what do we do to calculate K sub EQ?
Find the equilibrium.
Yeah, right? We get 8.96 times 10 to the negative second. Yeah. That's one of the things about this is repetition. All right, let's blow you guys underwater now. Dun, dun, dun. No. Time for hard mode. So we get 2A yields 2B plus C. This is our reaction. This is our initial concentration. What is our initial concentration for A? 2. How did you get that? Nope. Nope.
1.5.
3 divided by 1.5, which is 2. Call the opposite of Venus. So how much B and C do we have? 0.
0.
Yep. So for every 2x that we lose of this, we make 2x and 1x. Right? With me still. The the balance equation. 2 moles of A per liter make 2 moles of B per liter and 1 mole of C per liter. With me? And at equilibrium, 2 minus 2x, 2x, and x. Right? We know that K sub BQ equals B square, B A square. And we know that this is 2x squared times x over 2 minus 2x squared. And we know that K sub BQ equals 2.6 times 10 to the negative 6. And we know that this is 4x squared times x, which is 4x cubed. Huh? You can't keep up with my writing. This is exactly the way it is in every chemistry class in college. It's like the professor's got this board of dumb. I'm gonna let you think in for a second. I'm gonna grab another drink. So this right here, see if you can get down to this. All I'm doing is plugging in the thing. I'm not sure if I'm using that. They're very similar to those that you had, but I like these better. No. Now this is where you guys get lost. Boom, I'm gonna wait till you get your candy. No. But you could. Did you foil it and do all that and you solve for X?
Oh, wait.
What I'm gonna do is I'm gonna subtract 2.6 times 10 to the negative 6 from both sides. This is right here. I know, right? Who are you calling psychopath? You freaking, Leo's getting freaked out, by the way. Noah eats a jelly bean. And it's amazing. All right, this is getting tricky. So focus. Focus back. I agree. All right, so on your calculator, you have this math button. Go ahead and press that. Calculators. They are trolley dinosaur eggs or sour eggs or something. I thought the jelly beans were gonna, like, these taste more like jelly beans than jelly beans, I think. You're going to want to go to the solver function of that. And then up here, right, so hit math, press up to go to the solver function. And you will have an equation. That's why I set this equation equal to 0. Then clear them. Yep, that's what mine says, equation solver. It says what?
Oh, I told you that. How did you get there?
Math?
I thought I left before.
Math. Math solver 0 equals, and you may have a different version where you have 2 equations. Just put 0 in the top one, or you could just set it up with this as one of the equations and this is the other one. So we've got to now put 4x cubed over 2 minus 2x squared minus 2.6 times 10 to the negative 6.
Mr. Jackson.
Yeah.
I can't find the equal sign on my calculator.
Equal sign, I don't know what that means.
Like 0 equals, like I have to type in the equals and
Oh.
I can't find it.
Just hit up until it says that. Yeah. Up.
When you say up, do you mean like the up arrow?
Do you have the special where it says equation 1, equation 2?
Yeah.
Yeah, so put equation 1, put 0.
Yeah, I did.
Yep, just put it at 0. Yep. And then your equation 2, so basically the way yours looks, here, let me grab this.
Oh, is equation 1 and equation 2 on each side of the thing?
So the other thing you could do is just go negative 2.6 times 10 to the negative 6th up there. Yeah. No, I don't think so. How do you do that?
Oh, so like equation 1 will be 0 and equation 2 will be on the other, what's on the other side, and then it solves for x.
Yeah.
Okay.
There, how's that? Yes? You can, or you can set it equal. So on this equation, it's better because you don't have to set it to equal. If you have an older calculator, you have to set it equal to 0. So on the bottom here, we have to do this. So we have 4x cubed. And here we have parentheses, 4x cubed. Close parentheses. Parentheses are right here. Oh, this caret. So that right there is where we're at on each of these. So now we need to divide by 2 minus 2x. And I'm going to take and square this whole thing. Oh, it is. That's amazing. So there's one. Yeah, you're on the same computer as this one, so it's gonna be easier for you if I do this. Here's the other one. So now we need to parentheses 2 minus 2x, parentheses end, square. Now notice I have parentheses, open, parentheses, parentheses end, parentheses open, parentheses end. I need the end parentheses again. And then on this one, unfortunately, I have to subtract. And it should not be negative on this one. And then subtract 2.6 times 10 to the negative 6. And then did I hit that? And then, so I have this here. I want to replace that with 0. And then I hit enter here. And I want to replace this with 0 and hit enter on both of these. And the bound is basically just where it's taking these numbers from, that's all. And you can see that that's basically every number. Yes, no, I put 0 as the x. So I'm saying that this is 0, so I want the answer that's closest to 0, basically because I don't want a negative number. And then here's the tricky part. We hit alpha. And then the solve button. And then it takes a few seconds for it, and then it solves it. If you got this fancy calculator, you can just hit the solve button. Graph. Yeah, no, that calculator is way fancier, right? What did you guys think about that? Yeah. Now, real quick, this is just our x. So now we've got to go back and plug that in here, here, and here. And then we get these concentrations. 0.0136 is the x.
Yeah. I'm not gonna-
And welcome to 20-minute problems, right?
How many of these are gonna discuss?
2.
Not that bad.
And yeah, right? Otherwise, you'd have had to bust that out into the quadratic equation, there's the FOIL method and all that, right?
I don't feel like this.
For tomorrow, I would like for you to do 5, 6, and 7 of these. Notice on 5, they give you the KCBQ. And they want you to calculate the concentration of each species initially. Each species, if initially 1 mole of everything was put in there. So we have 1 mole of this, 1 mole of this, 1 mole of this, and 1 mole of this per liter. If K is 5, what is Q? What is Q for this one?
1.
Q is 1. Q is found the same way as K, but you put in all these ones in there, right? So you guys made it hard in your head, didn't you? 1 squared divided by 1 squared is 1.
It's 1 times 1 divided by 1 times 1.
Yeah. I don't know what steps I could have skipped there. 1 second. Forward or reverse? Why? K is higher than Q, so this should go forward. So what's that mean is going to happen to our reactant?
Reactants decrease.
Yeah, minus X, and our products
My brain is like 2 steps behind. but
plus
it's
X
like
and plus
eventually
X.
getting there, but it's like my brain-
What's that? 0.0126 with that. And then we had to plug it in. Talk about it, then. Math. guys get a chance to sign at least one of them?
Oh, it's not signed.
You could have signed both of them, it doesn't matter, but
Oh, there we go.
one is fine. That way you have more room for my other copies, right? I went 7 or 8 and got them. My birthday's actually Thursday. I don't know if I'm bored by then, but two ladies cards. You won't expect it this year because you did it last year.
If you had, is it over 1 year, then over.
That's all I've got, guys. If you have any questions, by all means, each one of these gets a little different and a little trickier. So try 6 and 7 for tomorrow, and then we'll do 17 and 18, and then tomorrow in class, and then review for the test for Thursday, and review Friday, and test on Monday. That's all I got, guys. Have a great day.
You can buy.